In this video, we're going to do a quick review of slope. I took some pictures here. If you go from left to right, you will see that this is actually Mr. G. So when Mr. G is going uphill, he's going puff, puff, puff. So the uphill is what we call a positive slope. Okay, so uphill is positive. When he's puffing, he's trying to stay positive to go uphill. And when he gets on top of the hill, he is skiing down like crazy. And that's when he is saying, this is really nice, negative. So this is a negative slope. This we say puff, puff, positive. Nice, nice, negative. That's when he's all happy. And right here we have a very happy Mr. G. And then he reaches the flat part and he says, this is zero fun. So Mr. G now is whining like a baby. And so because when he is on the flat surface, he thinks it's zero fun. So that's a slope. We call that the slope of that line is 0. And then finally, he jumps over the cliff. He goes crazy. And in algebra, when we go crazy, we have a term, we have a curse word called undefined, because you cannot define that slope anymore. Okay? So here are 4 very easy to remember slopes: positive, negative, 0, and undefined. And you can use these crazy pictures below to remember what it is like when Mr. G goes on a ski trip. Next, let's do some practices. There are different ways of calculating a slope. Probably the most welcome one is the rise over the run. And remember, it's rise up over the run out. What do we mean by that? We're often given a graph with 2 points. So we want to start from the first point. We rise up all the way here, right? We rise up to there, and then we run out. As we rise up, we measure this part. From this part is 1, 2, 3, 4. So that's the slope calculation for that is rise is 4, and when you run out, you've got 1, 2, 3, 4, 5. You run out by 5. So that 4/5 is my slope. Also remember, slope really is just the rate of change, meaning how fast did I go from A to B. Therefore, it's really a relationship between the rise, how fast it rises, versus how fast it runs. So a lot of students struggle here because the concept is so abstract. It's not just like distance, it's very concrete. It's one number measuring one thing. Here we are measuring 2 things, and this ratio and this fraction illustrates a relationships here. Okay? Same thing with the second one. And notice that that's positive when we go from left to right, just like how we write. It's positive, goes up. And now we're going downhill. When we go downhill, Mr. G is on the negative. So let's see. That if we go rise up from here to rise up, and then go to the left. If I go to the left, this is negative, right? When I rise up, this is positive. Compared to example 1, when I rise up is positive, I go to the right is positive. So now I rise up by 3, and then I go to the left by 6. So I have negative half. This is a negative slope. Therefore, it's going downhill. Right? And let's look at number 4 first. I have 2 points here. I don't rise, therefore my rise is a 0. and I run to the left by 3. It really doesn't matter how many I run. 0 divided by anything, that's a 0. So this is a 0 slope, meaning this is 0 fun for Mr. G, and that's the flat surface. Skiers don't like it when it's flat. And then finally over here, you have when you rise up, however this many is, this is 1, 2, 3, 4, 5, 6. And then when you run, you don't run. There's no running here. So the running is 0. And that's why this is called undefined. Undefined. Okay? Now, that's what happens when you're given a graph and given 2 points that the coordinates can be easily read by you. Another scenario is that you're given just coordinates of 2 points, and then you're asked to calculate the slope. You still do the rise of over run, but this time you have to calculate the rise, and we do that by using meaning calculate the distance of the rise and the distance of the run. So we use it by y2 minus y1, which is the rise, divided by x2 minus x1, which is the run, right? So let's look at this. We're asked to find the slope of AB. Therefore, the slope for AB, MAB, is -1 minus 5 over 6 minus 2. So I should have -6 on top, 8 at the bottom. My slope is -3/4. So we know that this is a negative, therefore it looks something like this. I'm not graphing it precisely, but that's the idea. Okay. Let's look at number 2. Same thing, you just plug it in. So you're asked to find the slope for GH. And again, that's 7 minus -3 minus 6 minus -11. And you should have 10 over 5, and that's 2. Now, you may say, let me change the color. I did 7 minus -3. What if I do the other way around? Will I still get the same thing? I'm going to set up a different color. So I still do it. In other words, it doesn't matter which one you do, y1, y2, as long as you're consistent. So this time I'm going to do -3 minus 7 divided by -11 minus -6. I still have this time -10 over -5, and I still have +2. So my final answer is exactly the same, but it doesn't matter which one you designate as x1, y1, as long as you're consistent. Okay, so if you do the number 7 and number 8, you will find that number 7, I'm just going to give you the answer here. Eventually, it should be 6 over 0. The answer of that, this is undefined. That's when Mr. G goes crazy. So that's undefined. And the last one, the answer is 0. And 0 is a flat. So it looks to me that they're flat at -3. Okay. So let's see. I think you have a sheet called Slope Practice. If you can finish just the odd numbers of the practice on that sheet, that would be great. And on the next sheet, which is what we're seeing here, there are some interesting things we can do about slope. One is about parallel lines, and the other is about perpendicular lines. So for parallel lines, they all have the exact same slope. So if you actually think about a mountain range, right? So when we look at mountain ridges, if they have, intuitively we say that they have the same slope, and it creates that sense of parallel lines, and that's because that's the mathematical translation, is that when their slopes are the same, these lines are parallel. Perpendicular lines have, pay attention, negative reciprocal slopes. And so, meaning negative, you have to change the sign from positive to negative or from negative to positive, right? You have to change the sign, and then you have to flip the fraction. So it's two actions you need to take in order to find that slope. So here are some examples for negative reciprocals. Negative of 3/4 is negative 3/4. I'm sorry, opposite of 3/4 is negative 3/4. And then I have to flip it and find the reciprocal, flip it. Okay? 2, opposite, then reciprocal. Negative 7/8 is a positive. 8 goes up, 7 goes down. 1 is simply negative 1/1. And 0 and undefined. That's undefined. Because once you flip a 0, 0 is in the denominator. It's undefined. So let's look at some example here. We're asked to use slope to determine if line AB and line CD, these are two lines, are they parallel, perpendicular, or neither? So then you have to, unfortunately, this is quite a bit of tedious calculation. So when you're given two coordinates, it's y2 minus y1 over x2 minus x1. So in this case, I have 3/4. Then I have to calculate CD, calculate the slope. Each line has its own slope, right? So 3 minus 0, then is 3 minus negative 1. I should have 3/4. So then I put in here, slope for AB is 3/4, slope for CD is 3/4, and they are parallel. Okay? Let's look at number 4. Let's do number 4. Let's calculate the first slope for AB. I have 6 minus 8 over 2 minus negative 1. That should give me negative 2/3. Then I calculate the slope for CD. I should have 3 minus 2, then 3 minus 1. I should have 1/4. So first slope is 2/3, second one is 1/4. They're not parallel, nor are they perpendicular, right? So now let's go back and look at number 2. If you calculate the first slope for AB, I would have 4 minus 2 over 5 minus 0, so I have 2/5. The second slope, I should have 3 minus 8 over 3 minus 1. That should give me 3 minus 8, yep, 3. So that should be 5/2. Negative 5/2. So the first slope is 2/5. The second one is negative 5/2. This is a 5. There we go. So this tells me they are opposite and they're reciprocal. So opposite reciprocal indicates these two lines are perpendicular to each other. So these are just some examples that I did for you. Let's do for the rest of the worksheet, finish all the odd problems, and make sure that if you don't understand it, pause the video, rewind it, rewatch it. The takeaway for this, if you want to go back and review it, is that we have to understand there are positive slopes, negative slopes, zero slopes, and undefined slopes. There are 4 kinds of slopes, and you can remember that with the ski trip made by Mr. G. And then in terms of calculating slopes, it's simply rise over run. If you know how to, if you're given enough information to read it off of a graph, you can calculate it. Or you can just calculate it using the formula y2 minus y1 over x2 minus x1. And then finally, we talked about how slope determines whether 2 lines are parallel or perpendicular, or neither, right? So that's all there is for the review of slope. Good luck, guys. Bye.